Now we will discuss what is decision tree classification is. Basically, classification is an unsupervised supervised learning technique. Now we will discuss what is decision tree classification is. It is a supervised learning technique, and whenever a data set is given to you, you will be converting that data set into a tree-like representation where user can easily understand the data without knowing the information what was there in a data set. See, generally tree structure format, it is having the root node, internal nodes as well as the leaf node. See, whenever a data set is given to you, which attribute you have to consider it as a root node, which attribute you have to consider it as a internal nodes. See, which data you will be considered as a leaf nodes. There, whenever in data set, we'll be having one class label, right? See, that class label will replicate the leaf nodes, and whatever the attributes are there, we need to make a decision that which node has to become root node, which node has to be considered as a internal nodes. For that, we'll be using three types of algorithms, either ID3 or C4.5 or CART. So these are the major three algorithms which you can use for taking a decision for either a root node, for whether which attribute we have to consider for a root node, as well as which attribute we can consider for internal node as well. See, in this video, we are trying to learn if we can consider ID3 algorithm, how it will work. Basically, if we use ID3, we need to calculate entropy and information gain for each and every attribute. See, similar, what is meant by entropy? See, entropy you will be calculated for each and every class as well as entire dataset is given, and information gain will be calculated for only the attribute. See, entropy can be calculated with logarithmic probabilities, positive probabilities of its logarithmic as well as negative probabilities of its logarithmic. And similarly, information gain can be calculated with same formula, which in turn positive logarithmic of positive information gain can be calculated with positive logarithmics as well as negative logarithmics with the difference of all the values in an attribute. You can understand these two formulas and their usage with the help of example. Let us suppose say I have given this data set. I just wanted to convert this data set into a tree-like representation form. Observe carefully here. In this particular data set, we have 14 attributes, out of which 14 instances. Observe carefully here, we have 14 instances and 4 attributes. Those are outlook, temperature, humidity, and wind. Out of which each and every attribute is having some values, which means that outlook is having sunny, overcast, rainy as values. Temperature, if you consider hot, mild, and cold as 3 values. And if you consider humidity, it is having high, normal as 2 values. Wind, if you consider weak, strong as 2 values. For all these 4 attributes of 14 instances is representing one class label, which means that play tennis, which means that with these weather conditions, whether a person can play a game or no. That means that with these conditions, whether a person can play, if they can play means the class label can be represented with S, otherwise it is no. So this is what the data they have given. So what we have to do, our motto is to convert these data into the decision tree format. See, we have 4 attributes: outlook, temperature, humidity, and wind. So which attribute you have to consider it as a root node? See, previously I said, so we'll be using ID3 algorithm. In that also we need to calculate entropy or information gain. See, this is the data set. Keep aside And initially, you need to calculate entropy. Here, S is a data set. S is a data set. Initially, you need to calculate entropy for entire data set. If you consider this particular entire data set, how many yes labels are attached for this particular class label? How many no's are there? Observe carefully. If you calculate yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 14, 9 are positive. 1, 2, 3, 4, 5. 5 are negative. So positive logarithmic versus negative logarithmic will give you entropy result, right? Minus 9 by 14. 9 are positive out of 14. And these will be again probabilistic value. You will be multiplying these two again. Difference with 5 by 14, which result 5 are negative out of 14 instances. Again, those negative instances will also give logarithmic value. These two differences will give the result of this particular entropy of data set. Later on, initially you have calculated entropy for entire data set. Now you need to consider one attribute, which is outlook. In turn, it is having three values, right? Sunny, overcast, rainy. So for these three values, you need to calculate entropy individually. See, for sunny, if you consider sunny values 1, 2, 3, 4, 5. 5 out of 14, 5 are representing sunny, out of which 1, 2, 2 are positive and 3 are negative, right? See, sunny values are only 5. So within that, 2 are negative, right? 2 are positive and 3 are negative. Here, minus 2 by 5 log 2 by 5 base 2, minus 3 by 5 log 3 by 5 base 2. This is the result. If you consider overcast similarly, it is having 4 values. All are positive. There are no negative values here. See, observe carefully. Whenever you are calculating entropy for a single value, if any of the attribute is 0, you can directly keep it as a 0. You don't need to calculate again. Or else, if both are similar, both are equal. Here, if you consider overcast attribute, it is representing 4. Let us suppose they assume that it is 2 positive and 2 negatives. That means that 2 class label values are similar. In those scenario, entropy will be 1. If any of the value is 0, entropy is 0. Here in this case, it is 0. And similarly, rain. So rain also, it is having 3 positives and 2 negative. We have calculated entropy for this also. Now, after that, you need to calculate information gain for entire attribute. Entire attribute, you need to calculate information gain. That will be calculated as entropy of entire data set. Initially, we have done that. And entropies of all data sets and its sum. See, if you expand it like this, entropy of S minus 5 by 14, which means that out of 14, 5 are sunny. Out of 14, 4 are overcast. Out of 14, 5 is rainy. So entropy of rain. So if you substitute all the values, you will get information gain of particular attribute, which is outlook. Likewise, see, till now what we have done, you have calculated information gain for only outlook. Again, you need to calculate it for temperature, humidity, and wind. Let's see. If you consider temperature, it is having hot, mild, and cold. And initial, what we have to do, we need to calculate entropy for the entire data set. Later on, you need to calculate entropy for 3 values, which are hot, mild, and cold. Later on, you need to calculate information gain of temperature data set. And again, you need to substitute all the values into it. So information gain can be calculated at entropy of entire data set minus, so summation of difference of all the values in particular attribute. So if you consider here 4 by 14, which replicates hot values out of 14. See, hot values in temperature attributes are 2 positive and 2 negatives. Totally it is 4 values. So that it is 4 by 14. Entropy of S of hot, this value will be represented here. And similarly 6 by 14. 6 by 14 means mild. So mild, it is having 4 positives and 2 negatives. Hence it is represented by 6 by 14. Out of 14, 6 are representing mild values. So entropy of mild, which is 0.91, you need to substitute here. Later on, minus 4 by 14, which replicates, so total cool values in a data set, which is 3 positives and 1 negative. So again, entropy of cool, this value 0.81 will be substituted here, so that you will get gain of temperature. So outlook we have calculated, temperature you have calculated, like gain you need to calculate it for humidity and wind as well. Consider humidity, which is having two possible values, high and normal. Initially you need to consider entire data set entropy, and later on you need to calculate it for both the values of humidity data set, which is high and normal. Again, you need to calculate information gain for humidity, and if you substitute all those values, you will get the result for humidity also. And we left with wind. You just take wind also. Wind is having again two values, which is strong and weak. And for initially you need to calculate entropy for entire data set, and later on you need to calculate entropy for strong and weak as well. You need to substitute those two values to calculate information gain for wind. Later on, after substituting all the values into it, you will be getting information gain for only wind. Now, if you observe carefully, we have calculated information gain for each and every attribute, right? See, out of which is having greatest value? See, outlook is having 0.24, temperature is having 0.02, and humidity is having 0.15, and wind is having 0.04, out of which outlook is having highest information gain. Hence, you can take this attribute as a root node. So that we have taken outlook with 9 positives and 5 negatives as root node. After that, you need to consider what are all the leaf nodes and what are all the internal nodes has to consider. Now, outlook is having 3 values, right? Sunny, overcast, rain. See, under sunny, we have 2 positives and 3 negatives. So that these are all the 2 positives and 3 negatives, total 5 values. 5 tuples are this: D1, D2, D8, D9 and D11. And overcast, if you observe carefully, overcast is having only 4 positive. There are no negatives here. Hence, if whenever root node with overcast comes, there is a possibility of only yes. There is no possibilities of no, right? Hence, I can directly represent here leaf node by considering class label as yes here. Later, if you consider rain, it is also having 3 positives and 2 negatives, total 5 values here, right? See, outlook is having 3 labels, out of which overcast is finished. We need to analyze that. What is the class label or what is the attribute we need to consider here in terms of sunny, and what is the attribute we need to consider in terms of rainy. See, out of 14, only 5 attributes are representing sunny, right? So what we have to do, we need to consider again those 5 attributes, those 5 values of outlook attributes sunny's value. Again, you need to consider these 5 data elements. Again, by considering this is as a whole data set. So that again you need to consider each and every attribute and their values. You need to calculate entropy of it. In again, information gain for each and every attribute. Here, if you observe carefully, we have calculated entropy of entire data set, but we are calculating only for Sunny. In before case, entire data set is having 14 attributes, but here Sunny is having only 5 attributes. Hence, we can calculate it minus 2 by 5 log 2 base 2, again minus 3 by 5 log 2 base 2. So this is the calculation for entropy of Sunny. In turn, again you will be taking attribute temperature. Within this, you will be having 3 values. You are calculating entropy of it based on these 3 values. You are calculating information gain. After substituting of it, you will be getting information gain of temperature. Similarly, you need to calculate it for humidity as well. As humidity is having 2 values, high and normal, you need to calculate entropy of it, later on information gain of it, so that you will get the information gain for humidity. Later, you need to calculate it for windy. This is the result you will get. Now, we have calculated information gain for these 3 attributes, out of which we will be having greatest value for humidity. See, initially we have constructed till this, right? So after that, we have evaluated 5 data tuples only representing the Sunny tuples. We have considered only 5 tuples which are represented by Sunny. Now we need to make a decision out of these 3 attributes, which attributes I should consider here. So ultimately, humidity with 0.97 is having greatest information gain. We need to add it here. So if you consider humidity high, we have 3 negatives, normal, 2 positives. So these are all this is the class label which replicates high with humidity. These are all the class labels which replicates normal with humidity. And similarly, what about rain? For rainy also we have 5 tuples. So again, you need to consider those 5 tuples which are replicating only rainy attributes. Later, you need to calculate entropy and information gain for temperature, humidity and wind. Hence, humidity and wind. Again, you will be getting those 3 values. Initially, we have 3 like this. After calculating it, we will be getting information gain for wind is high, so that in rain, we will be representing wind with strong 2 negatives, weak 3 positives. This is the construction of decision tree for 14 instances of a weather data set. See, initially the data set is given. When the data set is given, nobody will understand the data. But if you given that particular information in terms of visualization, in terms of tree-like representation, these kind of things, anybody can understand the data. See, here, if you observe here leaf nodes, each and every leaf node is representing yes or no, which replicates only the class labels of given data set. So where we have done most of the part we have done, while for calculating what attribute we have to consider it as a root node, what attribute we have to consider for internal nodes. So for this, we have taken an example of weather data set, and within that ID3 algorithm we have used, and within that also you will be using entropy and information gain, both formulas for construction of decision tree.